Okay, for question 2, this was just standard usage of SUVAT equations. So we had the question: a paratrooper jumps out of a stationary helicopter so that its initial velocity is 2 meters per second vertically downwards. So in this case, this is different to the stone questions. The paratrooper is actually falling downwards, so he's falling with gravity. Okay, so in this situation, he's falling to Earth at pace, and his initial velocity is equal to 2 meters per second. However, also, gravity is also acting in that direction, 9.8 meters per second. Okay. He falls freely under gravity for 1.5 seconds, and his parachute opens, and he descends vertically with uniform retardation for a further 22.5 seconds. His speed is 0 when he reaches the ground. Okay, so part A. Calculate the speed of the paratrooper just before his parachute opens. So if we think about it, first thing you do is write your SUVAT. Well, we know his initial speed was 2. We know that gravity is positive 9.8 because he's travelling downwards when he started, so that means gravity will be positive in this case because he wasn't moving against gravity. And we know that after 1.5 seconds his parachute opens, so we know that T is 1.5. What we don't know is V. So if we then think about this question in a bit more detail, we now know that we've got U, A and T, and we want V, so this is simply V equals U plus AT. And in many occasions, that's the equation that starts the whole question. Well, we know that V is what we want, U was 2, and A was 9.8 times 1.5. Okay? Carrying out that calculation, you should get 2 plus 14.7, which gives you a velocity of 16.7 meters per second. It's positive because he's going downwards, and that's what we set everything to be. Now, part B, sketch the graph of the velocity time graph for the paratrooper's descent. Now, I was a bit disappointed by this because there were some very poor sketches. So in the first instance, draw your axes nice and straight, okay? And we know it starts at 2, so his initial velocity was 2 meters per second. Remember, label your axes, time seconds, and basically he fell for 1.5 seconds, and we know after 1.5 seconds he hit a velocity of 16.7 meters per second. Then all that happened then after 1.5 seconds is he fell for another 22.5 seconds, which would take you to 24 seconds, where he hit the ground and his speed was 0. So a graph like that would be fine. Now what I noticed was we had curves here and here, which means the acceleration was not constant. Okay, so you must use a straight edge when you're doing a sketch like that. Okay. Then that leads us to part C. So part C was, how far did the parachutist fall? Well, again, you've got the velocity time graph there, and it's made up of 2 parts. It's made up of a trapezium, A, and a triangle, B. And most of you here thought that the paratrooper started with 0 and you worked out 2 triangles, which wasn't correct. Okay, so if we look at part A, we had in the first instance a half of the sum of the parallel lines times the height, which is 1.5, and that should have given you a distance of 14.025 meters. Then for B, we had a triangle, which is a half base times height, which is a half times 22.5 times 16.7, which was the height of the triangle. So base 22.5, height 16.7, which would have then given you a distance of 187.87 meters. When you add those together, you should have got a answer of 201.9 meters. I think for accuracy, I think it was 187.875 meters. So the parachuter dropped from a height of 201.9 meters.